Let's go through the math of this question now. Let's actually work through the partial derivatives. So we had the function and we have the constraint. We want to maximize it. So let's write the Lagrange and work from there. So we write our function again. Let me just make it 24x minus x squared plus 16y minus 2y squared, and then minus lambda times x squared plus 2y squared minus 11. Now remember, we want to take the partial derivatives, so the derivative of with respect to x has to be equal to 0. So that's going to be 24 from here minus 2x, nothing with x over here, minus lambda is the constant, keep it, times the derivative of x squared is 2x, and that should be 0. Now the derivative of the function with respect to y, so Lagrange derivative with respect to y is equal to, okay, nothing with y here, we have 16 minus 2 times 2y minus lambda is a constant, keep it like that, times, and here we have 2 times y squared derivative, that's just going to be 4y equals to 0. And keep in mind that we still have the constraint. We have x squared plus 2y squared is equal to 11. So that's our first order conditions. Okay, let's try and solve them. So what do we have here? Let's take that things with lambda to the other side. So we would have 24 minus 2x is equal to lambda times 2x, and here we have 16 minus 4y is equal to lambda times 4y. The constraint, we'll work with it later, no need to rewrite it all the time. Okay, let's make this a bit more comfortable for ourselves. Let's simplify them. So we can divide both sides by 2 over here, and we can divide both sides by 4 over here. So we would have 12 minus x equals to lambda times x, and then we have 4 minus y is equal to lambda times y. Let me make some space. Yes. Now let's take x to the other side as well and y to the other side. So we would have 12 is equal to x plus lambda x, and then here we have 4 is equal to lambda y plus y. So y plus lambda y. We just took this one over there and that one over there. Okay, let's take x as a common factor, and then here we can take y as a common factor. So let's do it. We would have 12 equals to x times 1 plus lambda left in brackets, and here we have 4 equals to y times 1 plus lambda. Okay, now we have 1 plus lambda on both sides. There's going to be a relationship there, so let's leave 1 plus lambda on both sides, so then we can see what's going to be equal. We can see that 12 divided by x is equal to 1 plus lambda, and 4 divided by y would be equal to 1 plus lambda. Well, 1 plus lambda equals to 1 plus lambda, which means that these two are gonna be equal. So we have 12 over x equals to 4 divided by y. Now we can cancel 12 and 4 by 3. So 12 divided by 4, we have 3. We would have that x equals to 3y if we do the cross product. X equals to 3y, and we also have the constraint. So let's substitute x equals to 3y in our constraint. Let me see where to go to have space. We have no space there, not here. Let me see above. Yes. And the constraint was that x squared plus y squared equals to 11. We found out that x equals to 3y, so let's substitute 3y into x. We would have 3y to the power 2 plus y squared equals to 11. Open the brackets, it's 9y squared plus am I right? I think it's x, okay, sorry, x squared plus 2y squared here, 2y squared, so 2y squared equals to 11, which means that 11y squared equals to 11, y squared equals to 1, y equals to plus minus 1. So we have two options. If we have two options for y, we will have two options for x. When y equals to -1, x has to be 3 times as large, so x is going to be -3. When y equals to +1, x is going to be equal to 3. Now we will check the values at x and y and see which one is the maximum, but we also need to know what is the lambda, because we want to give an interpretation of lambda so that all that our work that we did in the previous video will make some sense. Okay, how can we calculate lambda? We can just substitute a value into, where was it? It was somewhere here. 1 plus lambda equals to 12 over x. And let's say we found the value of x equals to 3. That was one option. So when x equals to 3, 12 over 3 is equal to 1 plus lambda, which means 1 plus lambda equals to 4, which means lambda is equal to 3. So at the solution where x equals to 3 and y equals to 1, lambda is equal to 3. And now in this case, when x equals to -3, let's see what value we would have. Actually, there's not much space to write next to it. Let's do it over here. It's the same. 4 over y equals to 1 plus lambda. We would have 4 divided the solution, let's use it, of -1 equals to 1 plus lambda. So -4 equals to 1 plus lambda, which means that lambda is equal to -5. So when y equals to -1, x equals to -3, lambda equals to -5. Okay, now what is the actual value of the function here? Let's see. If we I'm not gonna do the whole math because it can be done, you know, on the calculator. I just wanna save time on the video. The value when we substitute -1 and -3 into our results, we would get -99. So we would get here -99, and if we substitute this, and by the way, we substitute just, you know, just to make that point real quick, we substitute over here. We just put the optimizing values because we found out the optimizing value. For instance, 3 and 1, we have such a point, and the value is 77. The value is 77, and we can see that 77 is higher than -99. So it means this is going to be our this is going to be our maximum result, the maximum number of milkshakes. Speaking of our example, this is the max. How much did we use? We used 3 kilograms. We used 3 kilograms of what was it? Milk, and 1 kilogram of chocolate, and lambda is equal to 3. Now what does lambda show? Recall from the previous video, lambda shows how the maximum result, the maximum output, changes when the constraint increases by 1 unit. So if our constraint becomes not 11 kilograms on both, but constraint becomes 12 kilograms, meaning that we increase it by 1 unit, our result, our output, will increase by approximately 3 units, because that's what lambda is showing, the rate of change in our output relative to our constraint. So we would go from 77 milkshakes to approximately 80 milkshakes. I hope this makes sense. We are done.